Welcome back to another video. What I'd like to do is implement wall jumping. We already have wall sliding, but I want to be able to jump from the wall as well and jump up the wall. We'll also increase the size of the player and change the speed of the player and the jump force of the player just to make the movement a little bit more robust. Let's do it.
Game Dev Journey.
Alright guys, welcome back. First thing I'd like to do is to clean up the player's movement a little bit because the jump is feeling a bit floaty and the speed that the player moves at feels too quick to me. Also, the size of the player is a bit small. So let's start off by changing the speed constant here. Let's halve it to about 150. And I think when we increase the size of the player, that will improve the jump feel as well. So let's go back here. If you hover over the, well, we can see here that the pixels, the size of the textures are 32 by 32. Now I suggest making the player about 48 by 48. So how do we know what to scale this sprite by in order to get to 48 by 48? Well, if you divide 48 by 32, you get 1.5. So we should set the scale to 1.5. And I think that makes the player look a lot better. But now we will have to resize the collision shape as well. So if we go ahead and drag this down just to make it fit a bit better, I think that's fine right there. Let's save it. And let's just have a look how that looks in the level. If we run it, I think that's a lot better. The jump height is still excessive to me. I think he can jump too high. So I think we want to limit that a bit too. So if we go back to the player and we change the jump velocity here to, let's try minus 300 and see what that's like. So yeah, that's a much more realistic jump to me. Ooh, we got stuck there in that wall. The other problem I've noticed with the movement at the moment is, although we have a wall slide, we don't have a wall jump. So now that I've reduced the jump height, it's impossible to get these strawberries at the top. So let's go ahead and add a wall jump so that we can jump off the wall. Now, in order to jump off the wall, we're going to need to know which wall we're jumping off of, and we need a force or an amount of power with which we jump away from the wall. So let's add another constant here for the force, our wall jump force. So let's go ahead and say const wall jump force, and we'll make it a vector 2, and we'll have 250 in the x and minus 300 on the y. That's the force with which we'll jump away from the wall. Then let's add a variable so we can keep track of which wall we're jumping away from, the left or the right wall. So down here we can add a variable. Let's call it wall direction, and we can set it to 0. -1 will be left and 1 will be right. Now if we go down to our wall slide method, let's go down to wall slide. Here's our wall slide. So we're checking if we're on the wall, then wall sliding is true. But now we also want to check if which wall we're on, left or right. So if input dot is action, if input dot is action pressed, and we want left, left. Then we know we are on the left wall. So wall direction is -1. And wall sliding would be true. Okay, then if, yeah, we'll just do the same thing because it's going to be all the same. We'll copy that, paste it, and this will be right. Then this will be the right wall, and wall sliding will again be true. And just make this an aleph. And otherwise, wall sliding will be what is it? Is wall sliding will be false. And we'll move this out for now. So get rid of that. So the larger else outside still matches up. Okay, and then let's just see. Now we can handle the jumping in the wall slide. So what we can do here is say if is wall sliding, then we can set that velocity. Now this is going to set the friction to 100 no matter what. But it might be better if we take the smallest number between the current velocity and that friction value, which I think is 100. So we could say minimum velocity y and friction. So it'll take the smallest number between those two. And that's going to make our slide a lot more natural and slower. Now we can do the actual wall jump. So let's go ahead and do that here. So let's say wall jump. Because if input is action pressed, and it's just pressed because we're jumping, and it's our UI accept, then we will set our velocity in the x direction will be equal to our negative wall direction times by our wall jump force in the x. And our velocity in the y will be equal to our wall jump force y. So we're going to jump in the opposite direction and up a bit, obviously, because we're jumping. We should implement our jump double jumps because we're counting on the jumps as well. So that will be a double jump. And we can set wall sliding to false after that. And let's see what happens. Let's just test this without using this for a second. I just want to get an idea what it does. Let's see if that lets us wall jump now. So we'll run this. And there we go. Yes. And now we can go up. Still double jump, get everything we need. Fall through, everything still works. And there we go. So I just feel like the movement's a lot better now for the player. And we can still wall slide and we can jump while sliding. And let's just see if we enable that. Does that have any effect on the animations? Not really. But at least we're tracking the jumps now as well. Okay, so I just feel like the size of the player, the movement, the jumping, the wall jumping now, it's all a bit better. You will notice that there is one problem now with our code in that we can double jump infinitely and essentially fly or float in the level, and we need to fix that. And the problem is just with indentation. If we close this and come here to our newly introduced wall jump code, you can see that the indent means it is not part of the wall check. It's not, this will run all the time, not just if you're on the wall. So we actually need to indent this, tab this all in, so that it's part of this if statement at the top, so that if we run it now, we can't infinitely wall jump, double jump, but we can still double jump when we're on the wall. And next we'll implement the checkpoint. See you next time.